What if the thing you've been blaming for your laziness isn't actually the problem, but the messenger? Every time you scroll through your phone, skip the gym, or sit down to work only to find yourself doing anything but working, there is a chemical reaction happening in your brain that most people completely misunderstand. Dopamine has been called the pleasure chemical for decades, but that label has led millions of people down the wrong path when trying to fix their motivation. The real story is far more surprising, and once you understand it, the way you approach everything from your goals to your daily habits will never be the same. For most of the 20th century, scientists believed dopamine was simply the brain's reward signal. When something good happened, dopamine flooded your system, and you felt good. That was the model. It was clean, it was simple, and it was wrong. Researchers began noticing something strange in experiments with rats. When the pathway responsible for dopamine release was blocked entirely, the rats stopped moving toward food even when they were starving. They still showed signs of enjoyment when food was placed directly in their mouths, but they had lost all drive to pursue it. Dopamine was not about pleasure at all. It was about wanting, not liking. This distinction between wanting and liking changed everything neuroscientists thought they knew about motivation. The brain has two largely separate systems. One system drives you to pursue and anticipate rewards. The other system allows you to enjoy those rewards once they arrive. Dopamine powers the first system almost entirely. It is the engine behind craving, seeking, and striving. When your dopamine system is healthy and calibrated correctly, you feel pulled toward goals. When it is disrupted, you feel flat, unmotivated, and disconnected from things that used to excite you. That flatness is not a character flaw. It is biology. The most remarkable thing about dopamine is that it fires most intensely not when you receive a reward, but when you anticipate one. Researchers discovered this through a now famous series of experiments where monkeys were trained to expect a reward after a specific signal. Initially, dopamine fired when the reward arrived, but over time, the dopamine spike shifted entirely to the moment the signal appeared, before any reward was given. Your brain is constantly running predictions, and dopamine is the chemical score your brain gives to those predictions. This is why the anticipation of a vacation often feels more exciting than the vacation itself. This predictive mechanism has enormous consequences for how motivation works in everyday life. When you are working toward a long-term goal with no clear signal that a reward is coming, your dopamine system struggles to fire consistently. The brain needs cues, milestones, and signals that progress is happening. Without them, the internal drive begins to fade. This is the neuroscience behind why people abandon New Year's resolutions, why procrastination is so persistent, and why breaking large goals into smaller, visible milestones is not just motivational advice, but a direct application of how the brain's chemistry actually works. Modern life has essentially hacked this system in ways that previous generations never had to contend with. Social media platforms, video games, and streaming services are all engineered with one goal in mind, and that goal is to trigger dopamine release as frequently and as intensely as possible. Every notification, every like, every autoplay video is a precisely timed cue designed to keep your brain's anticipation system in a constant state of low-grade activation. The problem is not that these things feel good. The problem is that they are training your brain to expect rewards that arrive instantly and effortlessly, which makes slower, harder, more meaningful pursuits feel unbearable by comparison. Neuroscientists refer to this phenomenon as dopamine dysregulation, and its effects on motivation are significant. When the brain is repeatedly exposed to high-stimulation, low-effort rewards, it begins to downregulate its dopamine receptors. This means the brain literally reduces its sensitivity to dopamine in an attempt to maintain balance. The result is that everyday activities, things like reading, exercising, cooking, or having a real conversation, begin to feel dull and uninteresting. It is not that those activities changed. It is that the brain's baseline has shifted, and now it requires a much stronger signal just to feel engaged with ordinary life. This is why so many people today describe feeling unmotivated, even when their lives are objectively comfortable. They are not depressed in the clinical sense, and they do not lack ambition on paper. But they sit down to do the work and feel nothing pulling them forward. Researchers at Stanford and other leading institutions have studied this extensively and found that the modern attention economy has created a widespread pattern of what they call motivational blunting. The drive to initiate and sustain effort toward meaningful goals has been quietly eroded, not by personal failure, but by an environment that is fundamentally misaligned with how the dopamine system was designed to function. The good news is that the dopamine system is remarkably plastic, meaning it can be recalibrated. The brain that has been dulled by overstimulation can recover its sensitivity, but it requires deliberate and consistent effort. One of the most well-supported strategies in neuroscience research is what has come to be called a dopamine fast, not in the pop culture sense of avoiding all pleasure, but in the more precise sense of reducing exposure to artificial, high-intensity stimulation for sustained periods. When the brain is given space away from constant digital input, its receptor sensitivity begins to recover, and the natural motivation that was always available starts to return. Exercise is one of the most powerful tools available for restoring healthy dopamine function, and the research behind this is compelling. Physical activity increases the brain's production of dopamine, serotonin, and norepinephrine simultaneously, while also promoting the growth of new dopamine receptors over time. A study published in a peer-reviewed journal found that even 20 minutes of moderate aerobic exercise was enough to produce measurable increases in dopamine availability in key regions of the brain associated with motivation and goal-directed behavior. The effect is not just mood elevation. It is a direct restoration of the biological infrastructure that makes caring about things possible. Sleep is another factor that most conversations about motivation completely overlook, and its relationship with dopamine is more direct than most people realize. During deep sleep, the brain undergoes a process of synaptic restoration that directly affects the dopamine system. Studies conducted at leading sleep research centers have shown that even a single night of poor sleep reduces dopamine receptor availability in the brain's reward and motivation centers by a measurable degree. This is why a bad night's sleep does not just leave you feeling tired. It leaves you feeling flat, irritable, and unable to summon the drive to do things you normally care about. The fatigue you feel is partly physical, but the motivational collapse is chemical. The connection between dopamine and stress is equally important and far less discussed. When the brain is under chronic stress, cortisol, the body's primary stress hormone, actively suppresses dopamine production and receptor sensitivity. This creates a cycle that traps many people without them ever understanding why. Stress makes it harder to feel motivated. The lack of motivation leads to procrastination and unfinished goals. Unfinished goals create more stress, and the cycle continues, not because of weakness or poor character, but because of a hormonal feedback loop that operates entirely below conscious awareness. Understanding this cycle is the first step toward breaking it deliberately, rather than blaming yourself for something that was never entirely in your control. Nutrition plays a surprisingly significant role in dopamine production, and this connection has gained substantial attention in research communities over the past decade. Dopamine is synthesized in the brain from an amino acid called tyrosine, which the body derives from protein-rich foods. Diets that are chronically low in protein or high in processed sugars and refined carbohydrates can impair the brain's ability to produce adequate dopamine over time. Foods like eggs, lean meats, legumes, nuts, and certain fermented foods have all been linked in research to supporting healthier dopamine metabolism. This does not mean food alone can fix a disrupted dopamine system, but it does mean that what you eat is quietly shaping your capacity to feel motivated every single day. One of the most counterintuitive findings in dopamine research involves the role of uncertainty. While the brain responds strongly to anticipated rewards, it responds even more intensely to rewards that are unpredictable. This is called the variable reward schedule, and it is the same psychological mechanism that makes gambling so difficult to walk away from. The dopamine spike triggered by an uncertain outcome is significantly larger than the spike triggered by a guaranteed one. This is why mystery, challenge, and novelty are such powerful motivators when applied correctly. When you introduce an element of unpredictability into your goals, such as not knowing exactly when a breakthrough will come, your brain actually engages more intensely rather than less. This variable reward dynamic also explains why creative work and entrepreneurship can become so deeply consuming for the people who pursue them. Writing a book, building a company, developing a new skill, these are all activities where the outcome is genuinely uncertain and the timeline is unknown. For a brain with a healthy dopamine system, that uncertainty is not discouraging. It is energizing. The anticipation of a reward that might come, combined with meaningful progress signals along the way, creates a sustained motivational state that researchers have described as being among the most powerful natural drivers of human behavior. The key word, however, is healthy. A dysregulated dopamine system experiences that same uncertainty as anxiety rather than excitement. This brings us to one of the most practical and actionable insights that dopamine research has produced in recent years, and it has to do with the stories you tell yourself about your goals. Neuroscientists have found that the brain processes vivid mental imagery of future rewards in ways that are remarkably similar to how it processes real experiences. When you spend time genuinely visualizing a goal in specific sensory detail, not as a vague wish, but as a concrete mental experience, you trigger a mild but real dopamine response. This is not positive thinking as a motivational slogan. This is the brain rehearsing pursuit, priming the dopamine system to recognize and move toward a reward it has already begun to anticipate. The danger, however, is what researchers call mental simulation without action. Studies led by psychologists at major research universities found that people who visualized achieving their goals without also visualizing the specific steps and obstacles involved actually became less motivated over time, not more. The brain, having already experienced a version of the reward through imagination, reduced its drive to pursue the real thing. This is why daydreaming about success without a clear plan can quietly drain the very motivation it seems to be building. The most effective use of visualization is not imagining the destination, but imagining yourself doing the difficult work required to get there. Consistency, it turns out, is itself a dopamine strategy. When you perform the same action at the same time in the same context repeatedly, the brain begins to associate that context with the dopamine response that follows the behavior. Over time, the cue alone, whether that is sitting at your desk, putting on workout clothes, or opening a specific notebook, begins to trigger a small anticipatory dopamine release before the work even begins. This is the neurological foundation of habit formation, and it explains why people who have maintained long-term disciplines often describe their routines as feeling automatic and even pleasurable, not because the work became easier, but because the brain rewired itself to anticipate reward at the moment the routine begins. What all of this research points toward is a truth that is both simple and profound. Motivation is not a personality trait that some people are born with and others are not. It is not a matter of willpower, discipline, or character in the traditional sense. It is a biological state produced by a finely tuned chemical system that responds directly to the environment you place it in, the habits you build around it, the sleep you give it, the food you feed it, and the stories you tell it about what lies ahead. Every choice you make about how you structure your day is either supporting that system or slowly working against it, usually without you ever realizing it is happening. The most important thing to understand about dopamine is not how it works in a laboratory. It is how it works in your life, in the gap between knowing what you should do and actually feeling pulled to do it. That gap is not a mystery. It is not a flaw in your character. It is a signal from your brain that something in the system needs attention. And the extraordinary thing about that system is that it is never too late to recalibrate it. The brain you have today is not fixed. It is responsive, adaptive, and capable of recovering its drive when given the right conditions. That is not a promise. That is neuroscience.